अलमीरा में होगा, कपड़ा के पास। Jasmita, good evening. Hello, Varshan, good evening. Okay, let's start the book. Yashmit, good evening. Yashmit is there. Elavershan is there. Sharmila is there. Jasmita is there. Tarun is there. Okay, fine. Very good. Good evening, everyone. Just check your live button is on or off. So morning we have studied about very important points. We studied about electrons, and we came to know that 1 coulomb of charge consisting of 6.25 into 10 to the power 18 electron. Sophia is here. Good evening, Sophia. Very good evening to all of you. And it's very good that I'm seeing my children very curious about studying. Okay. Yes, Ella, super beta. So now understand this one. Kritika, good evening. Good evening, everyone. So now let's see here. So when we will be studying about this part, so study static current and current electricity. These are two things. Okay, Vishwa, good evening, beta. How was your game? Ashwita, good evening. Why, Ashwita, you were not there? So now look here. We're going to talk about static part. So static current will be exactly the current that is possessed. Good evening, sir. Vanakkam. So we are going to talk about static current, and we are going to understand what is exactly the meaning of static current. Okay. So the current which is Durga, good evening. Come on, yaar, check you are exactly live or not. Because if live will not be there means seriously too much light is there. I can't see actually. Fine. So now look here. I should move a bit because it's giving me seriously pain today. Now look here. So what we are going to do is glass rod and silk. So we were talking about static current and current electricity. These are the two topics. So when you will be talking about static current, you need to understand that when you will be talking about static current will be that current that will be exactly processed in the surface of the body. Current electricity will be present inside the wire. Okay, so that's different. Okay, switch off a light. If I will switch off a light, you won't be able to see the screen first. And then Archana, Dawn. Yes, Dawn, madam, you are here. You are madam or sir? I am having big confusion first. Huh? Madam or sir? Dawn only. Okay, that's better. You stayed on. Now listen. So when we are talking about rubbing a surface, so when you rub a surface, what I have discussed actually is कि when you will be rubbing a surface, why? Why there is no answer for that, but nothing just asked. So when you will be exactly one surface will be there, one rod we are going to take, dilemma of ma'am on our screen. Nothing like that. I'm just going to start my work. Now listen first. So you need to understand that ki when a surface will be there and when you will be rubbing the surface, see this is exactly electrically neutral. So if the surface is there, surface is electrically neutral. What is the meaning of electrically neutral? The meaning of electrically neutral is the number of positive charge is equal to number of negative charge. Okay, fine. But what we are doing is when we are rubbing the surface, just like glass rod is there. So this is the glass rod. So in this glass rod, you are exactly what you call when you are rubbing the glass rod with silk, then what will happen? It is exactly, yes, sir. Good evening. So now what is happening here is here when it will be you will be rubbing the surface with it. Good morning. So here positive charges will be generated. What charges will be generated? Positive charges will be generated. Good evening, beta. If you people will do like this means how I am going to teach you first say. Will be generated. So if positive charges are going to be generated, so that means what? The rod will be getting 10 positive charges and the silk cloth which is exactly rubbing it. First, though, this problem, that problem, full problem. I am also problem. Now look here. So that means woolen cloth or ebonite rod. So if you are going to rub woolen cloth is going to rub ebonite rod, then ebonite rod will be exactly having negative charge. Woolen cloth will be having positive charge. Okay. So it's not like that a rod will always acquire positive or negative charge. Okay. एक काम करूं मैं काम छोड़ करके तुम्हारा सारा प्रॉब्लम सॉल्व करूं यू टेल मी तुम्हारे मोबाइल में नोटिफिकेशन नहीं आ रहा है तो इसमें मैं क्या करूं बताओ now look here woolen cloth is there woolen cloth is positive charge and plastic is negative charge so whenever you are exactly fine I want peace to teach एक बार और बोला तो ब्लॉक करूंगी अब now look here plastic woolen cloth and glass rod so what we are going to do here is ki whenever two things are exactly going to rub each other at that particular moment one will be acquiring positive charge and another one will be acquiring negative charge and we know one more important thing that now one more very good bye so one more important thing is कि when you will be exactly having yes how much positive charges will be there on the surface that much negative charges will be present there so number of positive charge will be equal to number of negative charge and that's the case of electrical neutrality neutrality means no positive and negative coming from here and there how much positive is given to one surface that much negative will be given to the other and they will be considered as electrically neutral like dry hair is there and plastic comb is there so if you will comb like this means कि how much positive charge will be there on the comb that much negative charge so sometimes when dry hair you are combing the hairs will get electrically charged and will start getting up understood so that's the concept understood so some will be gaining positive charge and the opposite will be gaining negative charges okay you should be sorry so now look here, chapter deal with charges. So now we are going to talk about electric field. Now this is one of the most important topic from here. We are going to talk, yes, with dry hairs it is exactly coming. Yes, absolutely. When dry hair will be there, at that time when you are combing, means the hairs will exactly stand. Okay, so that part is exactly working. Now electric field. Now I'm going to talk about electric field. Morning I have discussed something. Now I'm going to carry forward those things. See, when the charges are at rest, they are generating a field called as electric field. When the charges are at rest, they are generating a field that is considered as electric field. I hope you might have understood this one. When the charges are at rest, they are generating a field that is considered as electric field. What it is considered as? Electric field. I hope you might have understood. The charges at rest. Ebonite rod is a type of rod, like glass rods are there, na? So ebonite rod is there. Okay, so that rod is exactly when you will be rubbing that rod. When you will be rubbing that rod, it will be having charges on it. Okay, Newton Baba ki jai. हाँ चलो कर ले. So here, what we are going to understand, the religion or the region of influence around a charge is called as region of electric field. See, you need to understand some point very nicely. The first important point to be noted here, see, Coulomb's law is not in your syllabus, first thing. What is there in your syllabus? I am just teaching that one. So you need to understand two things, that the region of influence. So what is the electric field? So where the positive charges or the negative charges will be accumulated, that will become the reason of electric field. That will become what? That will become the reason of electric field. Okay. So electric field is the sum total of the charges that is present into the region. I hope you might have understood this one. So interaction of electric, yes, Coulomb is the unit of charge. Okay, so now we are going to understand interaction of electric field between two charged particles will be there, and we already know that whenever a field will be generated, the intensity of the field is exactly dependent upon the amount of charges that is present there and how much field they are generating. Understood? So some of the electric field will be very effective, some electric field will be weak. So electric field, when it will be there, so morning itself we have discussed, Smriti, good evening. So morning itself we have discussed about electric field, and we came to know that whenever the charges is at rest, so that time when the charge is at rest, the amount of charges that is present inside a region is at rest, that time they are generating a field. But when they will be floating, when they will be moving, that time if they will be in motion, okay, when they will be in motion at that time, yes, when they will be in motion at that time, what is happening? They are generating magnetic field around. So if the current is flowing in this wire, that means magnetic field will be around like this. So perpendicular to the current field, magnetic field is generated. So it's not like that only current will be flowing in a wire. The perpendicular part of it will be exactly containing magnetic field. This is one of the most important concept. I hope you might have understood. Board is not visible. Ayo. Now look here. So here we are going to understand. I will move, then board will be nicely visible, you know. I am only going to move, board will be fully visible after that. See, just content I am showing you, I am only going to explain. एग्जैक्ट टाइम लाइफ का कितना है, कौन सा लाइफ का क्लास पूछ रही हैं आप? अगर पेडागोगी का क्लास पूछ रही हैं तो दैट इज 9 o'clock. सो पेडागोगी क्लास आफ्टर दिस अनदर क्लासेस एट 9 o'clock. 9:05 I am going to start, or 9:10 I am going to start pedagogy class. Now I am teaching electricity, and this is exactly class 10th content. Now look here. So now force of attraction, when we are going to talk about, so electric field potential, we are going to understand that Coulomb's law is not in your syllabus. Okay. See, look here. So electric potential and potential difference, you need to understand. Last time, this is the last time I am going to 2 minutes. I told right now only, first the chapter will be over, then only I will ask questions now. So if the chapter is not over, how I am going to interact with questions? I'm not drawing, okay? I'm not Dracula. Now look here. Just मैं जिस काम के लिए खड़ी हूँ उस काम को करने दोगे तब ना. Now look here, beta. You need to understand that amount of positive charge, that is exactly, see, what you are exactly doing is, now I'm going to talk about electric potential and potential difference. Okay. If you will allow me to speak about, I will explain you. Now one field is generated. Okay, in that field charges are present there, so that is supposed to be called as electric field. First thing, okay, the charges that is present in the electric field, that will be definitely impacting the energy or the charge which is coming from far. So just like in your home, you are 10-15 people are there. If some extra person is coming, then either you will be getting attracted towards that person or you will repel that person. That depends upon the type of repulsive force or the attractive force that person is generated. Understood? The type of attractive force or repulsive force the person is generating on you. Got it? So if a positive charge field will be there, means if positive charge field will be there and any negative charge will be exactly coming, so definitely it will be attracting. Understood? Because neutrality is one of the basic concept. But if positive charge field is there and positive charge is coming, then that positive charge will experience repulsive force. This is exactly the concept. I hope you might have understood. Okay, now look here. If a positive test charge is placed at a point A in the uniform electric field, so this is exactly a uniform electric field. So now in this uniform electric field, if you will be seeing, this point charge Q is there and this point charge we are keeping it here. Now this point charge will be exactly showing some repulsive or attractive forces. Okay, so now what it is exactly doing, so this is uniform electric field. Uniform electric field means the distribution of energy is exactly uniform. Understood? So here uniform electric field, a force will be exactly act on this charge along the direction of electric field. So in which direction the electron will be exactly moving, so at the direction of electric field, the point charge will be experiencing a force. It is just like your friends are going for a movie and 100% your friends will say, you come also with me for movie. So 100% there is a type of force there. So just try to understand a simple way. Okay. So that means what? You will also feel an experience like you all also wants to go to with your friends. Why? Because you are also, because your friends are of same type and they are going. So we say na company matters. Okay, company matters. Okay, so when it will be exactly like that, so when you will be in a company of that type of people, you'll become like that. Understood? So definitely if a point charge will be there and the electric field will be there, and the electric field will be flowing in that direction, that means it will be also experiencing some force in that direction. Okay, now you understand this one. If test charge QB, now we are exactly, so see the force exerted is this one. So in opposite direction, if it will be exactly placed, so in favor, in the flow direction it will be there, means it will go like this. But if the point charge is exactly placed in opposite direction, thank you so much, bye bye. So if it is placed in opposite direction, that means what? It will be experiencing a repulsive force. So electric potential, the amount of work done in a unit positive charge to move from one point to infinity to that point. Yes, that's the exactly definition of electric potential. Means what? What is potential? First understand. What is potential? First understand. What is potential? नेट मेरी तरफ से स्लो है, आपकी तरफ से नहीं मैडम. No, it's okay. It's okay. So you need to understand what is the meaning of potential. Potential means the amount of energy possessed inside a body. Got it? So we can say it as electric potential, means the energy that is stored because of position or that location, that is exactly considered as electric potential. Okay. Now what you are actually doing? You are doing what? And what one point charge is there, you are picking that point charge from infinity and you are bringing that point charge. Daksh, just understand one thing. इलेक्ट्रिक पोटेंशियल होता क्या है, पहले एक चीज समझो सिंपल वे में. पोटेंशियल क्या होता है? तुम्हारे अंदर जो एनर्जी है ना, वो तुम्हारा पोटेंशियल है. ठीक है? तो अभी कोई इलेक्ट्रिक फील्ड होगा, वो फील्ड का भी अपना एक एनर्जी होगा. एनी इलेक्ट्रिक फील्ड विल बी देयर, इट विल हैव इट्स ओन एनर्जी. आर यू अंडरस्टैंडिंग? So what that electric field will do, if one point charge will be there, so how it is going to show its energy? So how it is going to show that it is having the energy? What it will do, it will pick one point charge from infinity and bring it to that point. It is called as electric potential. Understood? So what is the potential difference? That the point, that the movement what it has done, that is exactly coming as the difference. Understood? I hope you might have understood. So now I hope you might have understood this point. Did you got it? So here, when somebody will be talking to you about, so if a positive test charge is placed in a point and it will be exactly experiencing the flow in the direction, what will happen? It will be getting attraction or repulsion depend upon the movement of the charges, the uniform field. Okay. So now potential difference. So what is the formula? Directly we will be exactly talking about the work done. Okay. So this is potential difference is equal to work done by charge, the amount of charge that it is exactly taking from infinity to that point. And this is the potential difference. This is what? This is potential difference. Now I am going to explain this one with the definition and the point here. So work done in carrying unit positive charge from point A to point B. So work done in carrying a unit positive charge from point A to point B. Okay. That is, we can say also work done in carrying a unit positive charge from infinity to that point. Okay. Or we can say that work done in carrying a unit positive charge from point A to point B is defined as potential difference between B to A. And this is exactly considered as what? Potential difference between points B to A. And potential difference point B to A will always be written as VB minus VI by work done. How much work is done? See, this is exactly because displacement is there. Now the charge is exactly moving, and the how much amount of charge is moving is Q naught. So this is the formula. So electrons are negatively charged, and it is exactly going to, please check this one out. The electrons, that is the negative charge in a conductor or a wire, flow from one end to the another end. So if this conductor, if there is electric pressure difference called electric potential difference between the ends of the conductor. See, in a very simple way, I am explaining. See, how can a wire conduct electricity? This is the most important thing. See, for that they need potential difference. A wire can conduct electricity if they will have potential difference, means the difference between the terminals. The terminals are positive terminal and negative terminal. Okay. So here to one simple concept I am telling, ki bhai, one thing is kept there, you have potential inside it. What you are going to do, you will pick that anything from one point and keep it in another point. So this is exactly. See, when you will be solving a question, we will solve some questions also. Don't worry about that. And the time when we will be solving these questions, we will be exactly explaining, because see, the questions are not difficult. Actually, the concepts first one you will be understanding, you'll be able to solve it. Okay, fine. Now listen. So so first we will understand some of it, and then we will be solving the questions. Okay. So if a point A is considered as a reference point, initial point, or the potential is zero at infinity, then it will be totally about VB location. Understood? So VB is equal to work done from infinity to that point. Because see, there are two different things. One thing is when we will be picking something from infinity, when we will be picking from something from infinity to that point. So when we are picking something from infinity to that point, that so infinity point we are going to take as the reference point or initial point. That time we are taking it as 0. Understood? And then another point, so VA will become 0. So work done will be from infinity to that point, and Q naught will be the amount of charge. Understood? So now we are going to do one work. What is the potential, electric potential and potential difference? So now can I ask one question from all of you? Are you ready for answering my question? Are you all ready for answering the question? Yes, this is what I'm wanting from all of you. Okay. See, listen, my simple question is why work done is involved in this? Why work done is involved in this? In potential difference, what is the work of work done? Let go. So what is the importance of work done in potential difference? What work done is doing here? What work done is doing here in potential difference, and why we are talking about potential difference is equal to work done by charges. Movement of electrons. So movement of electrons means what? Morning I taught one thing. Do you remember that part? That electrons, the charges will be needing what? The charges will be needing mass. You need to understand that the charges will be needing mass, but one important thing is the mass do not need charge. The mass do not need charge. That was the one most important point. That was, so displacement of charges is there. Work done is equal to mass into displacement, or force into displacement. Can you tell me? Work done is equal to force into displacement. Is it true? Yes or no? Work done is equal to force into displacement. Is it true or false? Come on, say. Then we will understand this, because current electricity is not a rocket science. Yes, yes, force applied will be there. Work done is equal to what, beta? Work done is equal to force into displacement. So here potential difference is exactly generation of the potential. Understood? So this difference will be generated. Yes, but here one thing you must understand: amount of point charges, the charges that is present, which is exactly moving, is also very, very important here. How much what you call charges you are moving from one point to another point, that is also considered as a part of work done. That is also considered as a part of work done. I am repeating, how much charges you are moving is also a part of work done, because the work done will be depending upon the amount of charges that is present into the field. Understood? And then only potential difference will be exactly telling the movement of these charges from one terminal to the another terminal, or from one point to the another point. So it is just like I picked this one and I kept it this point. Okay, so this is representing what? I took something here and I kept something here. So when I'm taking and keeping, actually this is why I did like this, because I have potential, I have energy, and with the help of this energy I took the charges and I left the charges in another location. So when I'm taking the charge and when I'm keeping the charge, what I am doing? I am doing work. Understood? So I took this much amount of charge, I kept this amount of charge in one place. What I did? I did work. Understood? So amount of charges, okay, the amount of charges what you are picking and keeping in other place, it is exactly the work done, and this is exactly requiring what? Potential. So when you have energy in the form of force, then only you will be able to pick, and then only you will be able to keep it certain location. This is the most simplest example I have given. Rather than that, whenever you will be understanding what is electric potential, means the amount of work done in taking a unit charge from infinity to that point, it is exactly potential. I hope you might have understood this one. So that this difference will be exactly between the two terminals will be there. Yes, you go washroom. Okay, fine, no problem. Now look here. So electric potential is exactly this. So infinity point. So if I will be taking anything from infinity and bringing to that point, so that time the potential at infinity will be considered as 0. Understood? So now what is the SI unit of electric potential and potential difference? So SI unit of electric potential and potential difference is joule per coulomb. Joule per coulomb. Why? Because SI unit of work done is joule and SI unit of charge is coulomb. So joule per coulomb is the exactly, and what is the name? We are combiningly calling it as volt. We are combiningly calling it joule per coulomb is 1 joule per coulomb. So we are going to understand this one. So here potential difference, I'm just writing P here, nothing. So to let you understand, potential difference is equal to work done by amount of charge. We can write it as V. So V is equal to W by Q. So work done by amount of positive charges that is present. Okay. So work done by charge. So when this work done, what is the SI unit of work done? Joule. And what is the SI unit of charge? Coulomb. So potential difference SI unit is joule per coulomb, and we are calling it as volt. What we are calling it as? Volt. I hope you might have understood this one. So this is exactly work done. So potential is equal to work done by charge. So potential difference is what? The movement of the charges from one point to the another point. I hope you might have understood. Did you understood this part? Please, everyone, come on, say now you understood or not. I have given very simple example. Yes. Oh, Praveen Raj, free fire. You understood? So I hope all of you might have understood this part. Come on, say quickly. Yeah, that's good. Good, good, good. All of you understood. That's a good sign. Good. I also understood. You understood means I understood. Fine. Now let's go for the next one. So my next question is, so we are going to understand, hey, charge is a scalar or vector? Charge is a scalar or vector? Come on, answer my question. Charge is scalar or vector? Who can answer me this question? Charge is scalar or vector? Come on, say. Charge is a scalar or vector? Who will answer this first? Charge is a scalar quantity or a vector quantity? Charge is a scalar quantity or a vector quantity? Who can answer me this? Come on, say. Scalar, 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 scalar. Yashwit is not giving answer. Charge is a scalar quantity or a vector quantity? Charge is a scalar quantity. Why? Because it is only having magnitude, but it is not having direction. Since charge is only having magnitude, it is not having direction. It is considered as a scalar quantity. Yes, absolutely correct. You people are absolutely correct. Charge is a scalar quantity. Understood. Okay. Yes, scalar quantity. Correct, Yashwit. So, Yashwit, check your live button. If it is not on means, then only answers are coming little late. Okay. Now look here. So electric potential, potential difference. What is the SI unit? It is volt. What is the SI unit? It is volt. Okay. So now sometimes now see, usually we are not expecting CBSE to ask definitions. They are not asking definitions because they know that if they will ask definition means we are very nice bucket. We will definitely take this and we will throw on the paper. So they will never, they never be asking this. They will be asking questions related to volt. Understood? So here you need to understand SCALAR. So now check this one out. 1 volt potential at a point means the work done in carrying 1 coulomb charge from infinity to this point. Understood? So 1 coulomb charge in carrying infinity to that point. It will be exactly called as what? Potential. 1 volt is defined. So this is the definition of 1 volt. What is the definition of 1 volt? That is 1 volt potential at a point means work done in carrying 1 coulomb charge. It is the amount of work done in carrying 1 coulomb charge. Only how much? 1 coulomb charge is exactly work done in carrying 1 coulomb charge from infinity to this point would be 1 joule. Understood? So here that's it is not 1 joule, it will be 1 volt. Okay, so 1 volt potential will be described like that only. 1 volt potential is described like this. So electric potential and potential difference are scalar quantity. That's what I have asked from you. It is to be noted that positive charge always move from higher potential to lower potential. This is another important point. Nice, very good. So now you please pay attention and try and understand one thing. If somebody will be asking you what is the direction of flow of charges, then here it is telling that it is noted that positive charge always flow from higher potential to lower potential. Always remember this one, that positive charges are flowing from higher potential to lower potential. Positive charges are moving from higher potential to lower potential. Similarly, negative charges move from lower potential to higher potential. So this is exactly the concept. This is exactly the concept we are going to follow. Okay, so this is what we are going to understand, like higher potential to lower potential, who is moving? Positive charges. Lower potential to higher potential, who is moving? Is exactly negative charges. So negative charges is moving from lower to higher, positive is moving from higher to lower. Positive higher to lower, negative lower to higher. Okay, so now we are going to talk about, see, smaller unit of electric potential. One all are the unit of electric potential. Come on, go for it. See, look here, smaller units of electric potential, 1 millivolt. Millivolt is smaller than volt. So millivolt is coming 10 to the power minus 3 volt. 1 microvolt is also smaller. This is smaller than millivolt. It will be coming as 10 to the power minus 6 volt. Larger unit of electric potential. So here kilovolt is there. So milli is minus 3. Kilo is 3. Remember, micro is minus 6. Micro is minus 6. So 1 microvolt, that is mu volt, will be 10 to the power minus 6. Understood? This is mu. So 1 microvolt is equal to 10 to the power minus 6 volt. It is how much? 10 to the power minus 6 volt. So smaller unit of electric potential. So mini volt is 10 to the power minus 3 volt. Microvolt is 10 to the power minus 6 volt. So large unit of electric potential. So 1 kilovolt is 10 to the power 3 volt. I hope you might have understood this one. So now we will be going for the next part. But 1 megavolt. So if somebody will be asking you about megavolt, so if somebody will be asking you about megavolt, then you will be saying that 1 megavolt will be exactly how much? 10 to the power minus 6 volt. So it's not looking clear. It is exactly 10 to the power minus 6 volt. It is coming as 10 to the power minus 6 volt. So 1 megavolt is equal to 10 to the power minus 6 volt. I hope till here everyone understood. Come on, say, did you understood this point? Till here, is it clear? Super, very good. Yes, super. So that means till here you have understood the concept. Nice. Super. So now, so how we can measure potential difference? How we can measure potential difference? If somebody will be asking you this question, that how can we measure potential difference? So you always remember potential difference will be measured with an instrument called as voltmeter. What is the name of the instrument? The name of the instrument is called as voltmeter. Now let's look here. The name of the instrument is called as voltmeter. Got it? So voltmeter is the instrument which will help. Yes, voltmeter is the instrument which is little bit confused. What happens, Smriti? We just, I hope you might have understood this one. So I'm just explaining this part. Please remember this one. So voltmeter is what? Voltmeter is the unit. It is the instrument. It is the instrument. Voltmeter is the instrument, and it is exactly measuring the potential difference. It is measuring the potential difference. Actually, you know what? The conventional direction of flow of current is from positive terminal to negative terminal. Positive terminal is exactly what you call higher potential, and negative terminal is considered as lower potential. So first, now we used to understand like this, that if we are drawing a circuit, so whenever we are drawing a circuit, this is exactly considered as higher potential, and this is exactly higher potential, and this is considering it as lower. Understood. Now look here, beta. So here we are going to understand one thing. This is exactly going to be positive terminal, and this one will be considered as negative terminal. So positive charges are moving from the flow of positive charge. But you know, conventional direction of flow of current is always from positive terminal to negative terminal. Okay. But actually what is the truth is, it's the flow of the electron. See, electron will be flowing from negative terminal to positive terminal. Electrons will be flowing from negative terminal to positive terminal. Understood? So now, Unnati, good evening. Electron will be moving from where? Negative terminal to positive terminal. I hope everybody might have understood this one. Come on, say me this one, that when somebody will be asking you flow of electrons. So flow of electrons will be from negative terminal to positive terminal, and the flow of charges will be always from positive terminal towards negative terminal. I hope everybody got it. Come on, say yes if you have finished. Yes, very good. So this is exactly the flow of electrons. Very good. So electrons will be moving from positive terminals or negative terminals. The electrons will be moving from positive. Yes, very good. So I think most of you who are present here, they understood one thing. What is the conventional direction of flow of current? So Yashwit, did you understood this one? So conventional direction of flow of current is from positive direction to negative. Conventional. I used a word called conventional. Did you notice I used a word conventional? But actually the current is exactly conducting the current. The conducting currents means the current which is responsible for what you call lighting a bulb or something. That is exactly running electrical appliances. That is the direction of flow is from negative terminal towards positive terminal, is from negative terminal towards positive terminal. I hope everybody understood this one. Come on, say, did you understood this point? Is from negative terminal towards positive terminal. Did you understood everyone, please? So what we have discussed here, first we talked about potential. Potential means the amount of energy required to carry a unit positive charge from infinity to that point. Understood? After we understood about the difference generated between moving that. Yes, ma'am, electrons already consumed in an electric circuit. Actually, what you are understanding about the concept of electron, first you need to revive it very nicely. See, it's exactly about the ions. It's exactly about the ions. Can I ask you one question? Can I ask you one question here? See, batteries are there. The batteries are exactly having, since the battery will be charged, till the batteries are charged, the currents are exactly, see, the bulb will glow. Once the battery will not be charged, the current will exact, the bulb will not glow. We know this point now. Why? Because need to understand very nicely. Till some chemical reaction will be taking place inside the cell, you know what will happen? Positive and negative generation will be there. So till potential difference is maintained in a circuit, the current will flow in a circuit. This is the most important point. Always remember, what did I said? I said a very important point, and that point is, please remember this part. Just 1 minute. Just please remember this point. Till potential difference is generated, till the potential difference is maintained in a circuit. What did I said? Potential difference is maintained in a circuit, the current will flow in the circuit. But if the potential difference is taken out, the current will not flow in the circuit. Are you understanding this part? Now, I was in voltmeter. You know what is the meaning of voltmeter? Voltmeter is an instrument which is fixed in, voltmeter is an instrument which is exactly fixed in a circuit to measure the potential difference of the circuit. Why? Because until and unless potential difference will not be there in the circuit, current will not flow. How much amount of current is flowing in the circuit, that means that is depending upon the potential difference. Understood? So that's many factors are there which is connected to it. Now first thing what we are going to understand, that a combination of cells is called as battery. What it is exactly? This is a cell or a battery? Come on, say. This is a cell or a battery having a positive terminal and a negative terminal. This is a cell or a battery. This is symbol of cell or battery. Come on, say anyone. Let's see. Very good, very good, very good. Super fast. Nice. Very good. Super. Very good. So this is exactly something which is very, very important. Now look here. So this is cell. So when we will be, the cell will have some amount of what you call, the chemical reaction will take place. So now this is exactly called as what? What is this? This is exactly, come on, say. Now this is what? This is a cell or a battery. Now this is what? This is a battery. Very good. The combination of cells are called as battery. The combination of cells are called as battery. Yes. The combination of cells are called as battery. This is one of the most important thing. The combination of cells are called as battery. The combination of cells are called as battery. Yes. The combination of cells are called as battery. Very good. So now beta, where we are going to use voltmeter? First, can you tell me where we are going to fix voltmeter? Are we going to fix voltmeter in the wire, or we are going to fix voltmeter in resistor? I'm asking this question. Are we going to fix voltmeter on resistor, or we are going to fix voltmeter here, which is the perfect location for fixing of voltmeter? Or we are going to fix the voltmeter V directly this? Is it a correct one? The answer is never. The voltmeter will never be connected in wire, because the voltmeter is not for connecting the amount, it is not for knowing the amount of current flowing in the circuit. Then where the voltmeter must be connected? The voltmeter must be connected here. This is the positive terminal and this is the negative terminal. So voltmeter is always connected in parallel. Understood? So either we can fix a voltmeter on a specific resistor, or we can fix the voltmeter on the entire battery. So when we are fixing the voltmeter in the entire battery, we are going to get the total amount of potential difference of the battery. Where we are going to get? We are going to get the total amount of potential difference of the battery. Okay. So when we are going to connect a voltmeter on a specific resistor, we will be able to know the potential difference of the resistor, specific resistor. You please remember this one. Now, what in all things are there? See, the work of voltmeter is to measure the potential difference. So, the amount of current flowing in it will be less. Understood? So amount of it will not allow, so its resistance will be high, amount of current flowing through it will be low. So this is the some important point at the that need to be understood. So where is the voltmeter connected? Parallel or series? Come on, say. This is called as series connection and this is called as parallel connection. Where is the voltmeter had to be connected? Where the voltmeter had to be connected? Please say. Very good. The voltmeter is exactly connected in parallel. Very good. So amount of current, yes, absolutely correct. The amount of current flowing, so it is exactly having high resistance. It do not allow current to flow through it. It is not allowing the current to flow through it. It is exactly allowing to measure. So here the resistance is high. So if somebody will be asking you what will be the resistance, your answer should be the resistance is high. Understood? And the amount of current flowing will be less. So potential difference knows, try to put the voltmeter tries to know the potential difference. So its resistance will be high, current flowing will be low. Its resistance will be high, current flowing will be low. I repeat my case, its resistance will be high and current flow will be low. I hope you might have understood this one. Resistance will be high and current flow will be low. Its resistance will be high and current flow will be low. So this is something we must know about. I hope you might have understood this one. So this is exactly something we are going to talk about. I hope you might have understood this one. Come on, say. Till here, is it okay? Till here, is it okay? Everybody, come on, say. Till here, is it okay? Did you understood the concepts very nicely? Everyone, come on, say. Yes, absolutely. Yes, Kritika, super. Very good. So we have learned some concepts, and in some part of the concept, we have learned about potential difference. Some we have learned about what you call work done. We will solve some numericals in next class. Okay. And then we talked about voltmeter. Is the voltmeter connected in series or parallel? What is the answer? The voltmeter is connected in series or parallel? What is the correct answer? Parallel. The voltmeter is connected in parallel. Very good. So it will have, will it allow current to flow through it? Will it allow current to flow through it? Is it allowing current to flow through it? Can you say me the answer? Is it allowing current to flow through it? uh-uh it is having high potential difference. It is having high resistance. Its resistance is high. Its resistance is high. Its resistance is high, okay, and it will allow maximum amount of current. That is what its work is for potential. Okay, now we are going to understand another thing. If we want to know the potential difference of the entire circuit, where we are going to put the voltmeter? Yes, where we are going to, where we are going to put the voltmeter? Where we are going to put the voltmeter? If we want to know the potential difference of the circuit, where we are going to put the voltmeter? Come on, say. Say fast. Where we are going to put the voltmeter? Battery. Absolutely correct. So if we want to know the potential difference of a resistor, then we will be fixing parallel to it. We will be fixing parallel to it. That's one of the most. Ammeter. Ammeter is a different thing. Ammeter is exactly measuring the amount of current flowing in a circuit. Voltmeter is measuring the potential difference of the circuit. That's the massive difference between ammeter and voltmeter. I hope you might have understood. So I'm having another class, children. So bye everyone. Bye for now. Good night everyone. I hope you might have liked the class. Thank you so much for joining the session. It was very nice. Okay. So notes, I'm going to revise the notes and send you as soon as possible in your respective group. Okay, bye. Good night. Good night, everyone.